When you open a fresh packet of tea to brew your morning cup, you're greeted by dark, dry, and crispy little fragments. But this everyday kitchen reality stands in stark contrast to where those fragments originate, as bright, highly hydrated, living green leaves covering mist-soaked mountain terraces. So how exactly does a vibrant, living plant transform into the brittle, aromatic pieces sitting in your mug? Bridging the gap between the misty mountain and your kitchen requires uncovering a heavily controlled, multi-stage process of physical and chemical transformation. Most people assume that radically different teas, like black, green, white, and oolong, are grown from entirely different species of plants. But almost all of the world's major commercial tea varieties come from the exact same botanical species, Camellia sinensis. This diagram illustrates how a single origin leaf branches into 4 distinct paths. Because the base plant is identical, the vast differences in color, flavor, and aroma you experience are dictated strictly by human-controlled processing methods. Creating tea demands more than simple agriculture. It is a deliberate, scientific manipulation of a single organic canvas. The agricultural stage begins with the selective harvesting of the top 2 leaves and a bud. This specific cut contains the highest concentration of flavor compounds. But there is an immediate biological hurdle. These freshly plucked, tender shoots are composed of more than 70% water weight. To handle this, factories rely on withering. The fresh harvest is spread over massive trays and subjected to continuous, controlled airflow for hours to extract internal moisture. This massive loss of water volume physically alters the plant, turning rigid, easily breakable leaves into limp, flexible material. Withering serves as a necessary biological prep step. It protects the fragile crop, making it durable enough to survive the intense physical engineering that comes next. Next is the mechanical rolling phase. Heavy machinery is deployed to forcefully twist, press, and contort the newly withered leaves. The objective here is microscopic. This violent rolling ruptures the internal cell walls of the plant, physically tearing them open to release their cellular fluids. By breaking these cells, the internal compounds are suddenly exposed to oxygen. This triggers a vital chemical reaction known as oxidation. As this oxidation reaction continues, it actively shifts the physical color of the leaf from a vibrant green to a deep brown, while simultaneously developing its rich, recognizable aroma. This timeline maps the color spectrum of that exact reaction, a critical fork in the road. If engineers halt oxidation early, the result is green tea. Conversely, allowing the reaction to run to its natural end produces black tea. A tea's final flavor and color identity is dictated not by the seed it grew from, but by precisely when humans stop the clock on chemical oxidation. That oxidation clock must be permanently stopped, otherwise the exposed leaf will simply rot. This leads to the food engineering stage of drying. Industrial dryers blast the leaves with extreme heat to instantly lock in their current chemical state. Due to the extreme moisture loss from the initial withering and this final drying, it requires several kilograms of fresh green leaves to yield just 1 kilogram of finished tea. This drying stage completely transitions the product from an active, decaying botanical specimen into a perfectly stabilized, shelf-ready food product. Before hitting the shelves, vibrating mechanical screens categorize the stabilized tea leaves strictly by physical size. This simple size sorting divides the batches into whole leaf, broken leaf, and dust grades, the exact metric that dictates the market quality and final retail price of different products. The physical appearance of the tea inside your kitchen packet was entirely predetermined by the specific mechanical screen it fell through. Yet, despite all the precise industrial machinery involved, the ultimate test still relies on highly trained human senses. Laboratory experts evaluate the final infusions based on precise color, aroma, and taste profiles to confirm the chemical processing was flawless, which brings us right back to your kitchen and your morning cup. The next time you take a sip, remember that your cup holds a months-long symphony of agriculture, biology, chemistry, and food engineering.